This is a look at question 10, which talks about the cosine from 0 to pi. I think this will illustrate the example. We'll go through this for all three of these, and I'll leave number 11 up to you. But LRAM for this, if I want to go from 0 to pi, we need to cut off the entire right side of that. So we're just going to do a little erasure of all this. That way, we're only looking at this segment from 0 to pi. And I might clean this up just a little bit so that I've got it a little bit more evenly split. So let's just slide this over to the middle to do my eta from here and then down to here. Okay, I want to divide this into 4 subintervals. So I need a point here, need a point here, I need a point here, I need a point down here. And then for LRAM, which we'll do this in green, I'm going to do here, down, then here, down, then here, which is just the axis, and then finally here and down. And we need to know what the values are at these individual points. So this is the cosine of pi over 4. So that's root 2 over 2. I'll just kind of put pi over 4. I know that this is the cosine of pi over 4 is root 2 over 2. And LRAM says that this is an area of pi over 4 times root 2 over 2 plus, pi over 4 times, this is a height of 1. I drew the 0 there, but really that 0 should be down here. I should mark this as a height of 1. So my bad, this is pi over 4 times 1 plus, then the width of pi over 4 times root 2 over 2. That'd be the next one. Plus, then pi over 4 times a height of 0. Then plus pi over 4 times, this height is negative. That was the instinct that a couple of you may have had. So this is going to be plus negative root 2 over 2. And so when I add all this up, those two will cancel, this will cancel, and my LRAM should just be pi over 4. And if we look at Desmos on the link that I sent you, here's what LRAM would look like on that. And if I scroll down, I get this value, which is 0.7 times 4 would be about what it would need to be to get. That's about pi over 4. So yeah, that should work out just fine. Now, then we want to change to RRAM, which once you do one of them, it shouldn't be too difficult to do the others. So let's try RRAM on this. RRAM. RRAM, let's try to erase all these markings, and we'll do RRAM in a different color. So RRAM is where the top right point is on. So this, then we get this one, and then finally we get this one. So really what's happening is it's actually the same, but negative. RRAM is, if I calculate the area of this and this, those will cancel each other out. So manually, I get pi over 4 times root 2 over 2 plus pi over 4 times 0, then plus pi over 4 times negative root 2 over 2, and then finally pi over 4 times 1. But that was negative 1, so this should be negative pi over 4. So the one right above it is pi over 4 for LRAM, and the one below it is negative pi over 4. Pi over 4 as negative pi over 4 for RRAM. Let's go back to Desmos and verify that that is actually happening. It says, let's make C equal 1 for right approximation, and yep, we get a negative of exactly the same value we just did. Midpoint sum, you're going to need a calculator for, and I'm going to put the exact down, but it's going to be up to you to kind of figure out where that is. So for midpoint, this is a lot more tricky than it looks. Let's draw it, and let's pick a different color. So we'll go, we'll go orange. No, orange is terrible. I'm already using it. We'll go gray. Okay, so midpoint, I'm going to go from here to here. Then I'm going to point here to here. Then I put the same point here to here, and then the same point here to here. So midpoint, MRAM, is going to be equal to pi over 4 times, this is going to be the cosine of pi over 8, plus then pi over 4 times the cosine of, this would be 3 pi over 8, So we get pi over 8, 3 pi over 8. Then we go plus pi over 4 times the cosine of 5 pi over 8. Oh, nope, this isn't. Wait, no, this is right. Pi over 4, this is pi over 8, 3 pi over 8, then 5 pi over 8, and then finally we have plus pi over 4 times the cosine of 7 pi over 8. What I was getting at with this is that if you look at these values, the pi over 8 and 7 pi over 8, the angles themselves occur here and here, so they are opposites of each other. The cosine of pi over 8 should be equal to the negative cosine of 7 pi over 8, just based on where they are on the circle. We can actually see that from the graph, too, that this area and this area look to be each other's opposites. And the same relationship is going to hold true with the middle two as well, that this and this should be each other's opposites, just like the cosine of 3 pi over 8 and the cosine of 5 pi over 8 should be each other's opposites. So this should be 0. And if I look at MRAM on this curve, or on this thing here, let's go to 0.5. I can see the areas are canceling, and I go all the way down, and I see this number here, 1 times 10 to the negative 16th, which is pretty much 0. So that's that. And then finally, trap. If I want to do trapezoidal rule on this, I know it didn't ask that. Remember, trapezoidal is the average of LRAM and MRAM, which we could see that would be 0 as well. Trapezoidal is not always the same as MRAM, not by any means, but here it happened to be.